Hi everybody, welcome back to the videos. This is Unit 6, Lesson 1, and I'm not sure if you can see me or not because I'm having some problems with my new software here, but if not, hopefully you can hear me. We're in our Unit 6 notes, and I just want to talk about the definition of a bond today and then what happens to energy when we make and break bonds. So it used to be that I thought a bond was a physical structure, kind of like a toothpick between atoms, and the reality is that that is not what bonds are. What a chemical bond is really a force. And it's a force of attraction between two atoms. And that force holds those atoms together and allows them to behave as a molecule, allows them to behave as a unit. And there's different reasons that things can be attracted to each other, but usually it's because of opposite charges. We'll talk about how those bonds are formed later on. So a chemical bond is a force of attraction between two atoms, and that force is strong enough to hold those atoms together. Thank you, Joanna. Okay, so it's a force of attraction between two atoms that holds the atoms together. Chemical bonds form for different reasons, but generally chemical bonds form because atoms need to have a full outer shell of electrons. Because a full outer shell of electrons is stability, it's happiness. That is electrons, even though that looks like a funky S there. We call a full outer shell of electrons a noble gas electron configuration. When we talk about how atoms form bonds, atoms must bump or collide in order to form bonds. So it's always the outside of an atom that's making the bond, and the outside of the atom is called the valence electrons. So usually only the valence electrons are involved in bonding. Okay? So again, we form chemical bonds in order to have a full outer shell of electrons or a noble gas configuration. The atoms are happiest that way. That's when they're in their lowest energy state, that's when they're stable. Just to remind you, I know you don't have this on your paper, but if your outermost shell is the first ring around the nucleus, that's full with 2 electrons. Any other valence shell is full with 8 electrons. So unless your valence shell is the first shell, you need 8 in order to make you happy. All right? What happens to energy when bonds are formed? Well, when I said that we form bonds, we become happier, we become more stable, we have less energy. So when bonds are formed, some of the energy that the atoms had when they were separate is given off, it's released. So energy is released when chemical bonds are formed. That's why explosions happen, because bonds are being made. If bonds are being made, a lot of energy is given off. Depending on how many bonds and how strong they are, the more energy is released. So as a result, if energy is released, there's less potential energy stored in the bonds, in the molecule. So making bonds is an exothermic process. When the energy is released, it's given off in some form, light, heat, whatever. But then if you have the compound and you want to break that bond back, so when you make bonds, energy is given off, if you want to break the bond, it takes energy. You'd have to put the same amount back in. So the energy released when a bond is formed is equivalent or equal to the energy needed to break that bond. And that we can express the relationship between energy released and bond strength. And that relationship looks like this. The more energy released when bonds are formed, the stronger and more stable the bond is, because that means it takes more energy to break the bond apart. Okay? Given that, there is a question at the bottom of this page, right here, that I'd like you to answer. Okay, so based on what we just talked about, based on that statement you just wrote, please, out of the choices below, I think the question's here, circle the bond that you think is the most stable. That's what I'd like you to do to make sure you understand that relationship. So just circle the bond that you think is the most stable. And that's it for tonight. Tomorrow we'll talk a little bit about ionic bonds. All right? Have a good night, everybody. Bye-bye.